Okay, today's lesson is Chapter 9, Lesson 4. It's on subtracting mixed numbers. So our objective is to subtract mixed numbers with unlike denominators. So up until now, we've subtracted from a whole number from a mixed number from a mixed number with like denominators. But today we're going to take it one step further and do it with unlike denominators. So you're adding another step to your process, okay? So let's look at the example on page 192. The oak tree named Old Glory was the largest tree ever transplanted. Does anyone not know what transplanted means? Okay, it means they literally uprooted the tree, dug it out, and then replaced it somewhere else. Yep. So it was moved to a new park in Los Angeles on January 20th, 2004. Okay, so in 2004, Old Glory, so in 2004, I'm just going to call it OG, Old Glory, was 16 and 1/6 feet around. So you got to think of circumference, okay, like you're hugging the tree. That same year, the oak tree in Annie's yard, okay, so Annie had an oak tree, was 5.5 feet around. How much larger was Old Glory's circumference compared to Annie's tree? So what are my keywords here in the question that it's asking me that tells me what operation I need to do? Yuna?
How much larger was Old Glory?
Right, and when you hear how much larger, what does that tell you?
It tells you that you need to subtract.
Very good. So I need to subtract, okay? So I need to take these two numbers, and I know I need to subtract because of that how much more, right? You're comparing two things. So I'm going to take the 16 and 1/6, and I'm going to subtract that from Annie's 5.5. Now, like I said, we're going to learn how to subtract with unlike denominators. The 2 and the 6 are not the same denominator, correct? And then what did we learn about fractions with unlike denominators? What are two options for how we can make them the same? Milana, what are our two options?
You could first see if they're multiples of each other, or you could find the greatest common factor.
Right, and you can do that by, what do you do with the two denominators?
You times them together.
Right, you multiply them together. Very good. Well, let's look at the first method. Is it a multiple?
Yes.
Is 2 a multiple of 6? Or 6 a multiple of 2?
No.
Which one?
2 multiplies
2 is a multiple of
6.
6. So do we need to multiply these two denominators together?
No.
Could you?
Yes.
Yes. Okay. So let's make it into 6. So 16 and 1/6 is not going to what? Change at all. So, but we know that the half is going to change. And when we do that, we take 1/2. 2 times what will give me 6? 3. Very good. And I do that, whatever I do to the denominator, I do to the numerator to the top, right? 1 times 3 is 3. So I have a new fraction there. Don't forget to bring the 5 over, okay? So now I have a new subtraction problem. But like yesterday, I see that 1/6 minus 3/6 is impossible. I do not have enough to subtract. So what am I going to do? Varsha, what am I going to do?
You can add with 6.
And where am I getting that 6/6 from? Who am I borrowing from?
16.
Very good, from the 16. Awesome. So I take a whole away from the 16, and I add on a 6/6 here to give me now a new fraction of?
7/6.
Very good, 15 and 7/6. I'm going to rewrite over here because I'm running out of space. Subtract 5 and 3/6. Now do I have a problem that I can do?
Yes.
Okay. So I have 7/6 minus 3/6, which gives me 4/6. Very good. And 15 minus 5 is 10. Now, is this in simplest form?
No.
4 and 6 are both even numbers, so I know that they are divisible by 2. So divide each side by 2. And my new simplified fraction is 10 and?
2/3.
Very good. Am I done?
No.
What am I missing? Label. What was the question asking me for? How much larger was Old Glory's circumference compared to Annie's tree? So what is my measure? What is my measure? Everyone?
Feet.
Awesome. So 10 and 2/3 feet, what? Not taller, remember?
Larger. Width.
No. If I'm hugging the tree and I'm looking at circumference, farther,
In diameter.
it is the diameter, correct. The diameter is greater, and we can say farther around, okay? Like you're putting your arms around the tree. So it's 10 and 2/3 feet farther around than Annie's tree. Oops. Farther around. Oops. Than Annie's tree. Okay, let's look at number 1. We have here 4 and 1/3 minus 2 and 1/5. Okay? And the directions say subtract and write the difference in simplest form. So that's another key word, difference, right? Difference means subtract. Every time I see that word, I should automatically think in my head, okay, I need to subtract. Okay, so let's look at the denominators. Are they the same?
No.
Are they multiples of one another? So we need to go with the second method that Milana mentioned earlier, and we need to multiply the denominators together. So if I multiply 5 and 3 together, I get 15. Very good. So now our new denominator is going to be 15ths. Okay? So let's start with 1/3. So 1/3 is equal to how many 15ths? Times what? Times 5. Times 5 equals 5 15ths. Very good. And 5 goes into 15 how many times? Times 3, the other denominator, right? 1 times 3 is 3. Do not forget to bring your whole numbers over, okay? Okay, now can I subtract 4 and 5 15ths minus 2 and 3 15ths? Yes, I can. Start with the fractions first. 5 15ths minus 3 15ths, everyone?
2 15ths.
Awesome. And 4 minus 2 is?
2.
Very good. My answer is 2 and 2 15ths. Remember, yesterday I talked about checking our work. If I add 3 15ths and 2 15ths together, I get 5 15ths. And if I add 2 and 2 together, I get 4. Does that add up to my other digit? My other number?
Yeah.
Yes, then I know it's correct. Okay? Okay, so let's take a look at number 2. Okay? We have 9 and 9/10 minus 4 and 2/5. Okay? So I'm not able to do this problem yet because I have different denominators. Are they multiples of one another?
Yes.
Alrighty. Okay. So 5 is a multiple of 10. So we're going to change this into tenths. Okay. So how many times does 5 go into 10?
2.
Times 2 times 2. 2 times 2 is 4. 9/10 stays the same. So 9/10 minus 4/10. Is that possible now? Okay, 9/10 minus 4/10 is? And 9 minus 4 is? Now, is this in simplest form? No, it's not. What can I divide 5 and 10 by? Gotham? 5, awesome. So if I divide by 5 on each side, I get 5 and 1/2. Very good. All right, let's take a look at number 7. We have 11 and 1/4 minus 8 1/2. Now remember, for me, I like to see things vertically up and down. That may not apply to you. You may like to do it horizontally. Remember, do what works for you. Okay? So we have 11 and 1/4 and 8 1/2. Are they multiples of each other?
Yes.
Okay, so what is a multiple of what?
2 is a multiple of 4.
Very good. So we're going to change this into fourths. So 2 times what?
2.
Very good. Times 2 is
4.
2 fourths. 1/4 stays the same. Can I subtract 1/4 minus 2 fourths?
No.
Nope. So what do I need to do?
Oh.
Arushi, what do I need to do? Mm-hmm.
1
Uh-huh. From,
from the 8.
not from the 8. What number doesn't have enough? Is it the 1/4 that doesn't have enough or the 2/4?
1.
Correct. So what whole number goes along with the 1/4?
10.
The 11, right? So you're going to take 1 away from the 11 to make it a 10, okay? And then you're going to add on the whole, which gives you now,
5/4.
very good. So 5/4 minus 2/4 will give me 3/4. And then I go back to my original problem over here. 10 minus 8 is 2. So bring the 2 over here too. Okay, so now my answer is 2 and 3/4.